So AI, as I mentioned, is about data, finding patterns in data and using those patterns. So that means that we'll use data, a lot of data, and a lot of computational horsepower to find those patterns in the data. So those are the two things that we need. We need data and the computational power to work with that data. So we can see now that we have machine learning that's spreading everywhere. Internet has given us a lot of data. Computers are becoming more and more powerful. I was talking about how the computers of today have more capacity, more RAM, more storage, all these other things that they have to make them more powerful. You know, my smartphone is probably more powerful than a computer that a billionaire could buy. You know, like it's like 20 years ago. It's like it's insane how much has improved. So the three categories of machine learning. Does somebody want to read out supervised machine learning?
I can read it, like the words underneath it.
Yes, please.
Okay. Given a few examples, ground truth, can you predict the outcome?
Awesome. Thank you. Thank you, Alyssa Ann.
Mhm.
So can somebody read about unsupervised machine learning?
No
Okay.
examples given, but can you distinguish patterns within data?
Okay. Thank you, Tanvir. Yeah, no examples are given. Can you find patterns within the data? Then we have reinforcement learning. So I think Lachlan, did you want to read on this? Oh, okay. Somebody else can read this then.
I can.
Mm-hmm.
If we want to maximize some reward, what actions you should take given what you have observed?
Yes, thank you, Brianna. So thank you guys. So for the COVID mask problem where we tried to predict, are you wearing a mask or not? So what type of machine learning do you think it was? Okay, Lachlan said, yes, Sarah?
I think it's supervised machine learning.
Okay, awesome. Thank you, Alyssa, and why?
Oh, you're talking about the masked one, right?
Yeah, the mask one.
Because you had to have to give the computer lots of data. So like given them examples, and then yeah, like with mask and no mask, and then kind of like learn from that. I don't know.
Yeah, no, that's awesome. Thank you, Alyssa. And yes, it's supervised machine learning because you have to give data on masks and no masks. So, and you can predict the outcome. So it's either you are wearing a mask or you're not wearing a mask. And you had to give lots of examples of people with masks and people without masks. And I think Lachlan had also said supervised a great job. And it's like the analogy that Lachlan also mentioned that is like training a toddler. So my sister has a cute little 3-month-old baby, and now when she's training the little one, she has to keep saying, okay, this is good, this is bad, good, bad, like fire bad, this thing good, right? When you're training a baby repeatedly, oh, Lachlan, okay. So pretty much the idea is that you have to give lots of examples. This is somebody with a mask. This is somebody without a mask. And now Nikhil, because there was an error made for you and not identifying you as a mask, or as firstly identifying you and then identifying you with a mask, then we'd have to update the data as well. Maybe take you and say that you're wearing a mask and then send it as data and then train it, like on a virtual background. Maybe it did not recognize it, but then it recognized my background. So why? So we need to keep on training that data and giving lots of examples. And then from that, it will sort of learn kind of like a toddler, like what's good, what's bad. If a toddler keeps watching these little cartoons where a villain is one way, it could even predict that maybe if, somebody's dressed up like the villain, if all villains have huge, big mustaches and something else, or all villains wear black colors, like a thug, then maybe the baby might start thinking that some friend, if you're a parent and you have a little baby, and it could predict that, okay, the baby will say that baby's a villain, mommy, daddy, that baby's a villain. I mean, that person's a villain. right? If they've only been trained on people who are wearing all black as being villains in movies. So, so then what do you guys think about reinforcement learning? Like, what do you think an example is that we talked about? Maybe one of the first examples that we saw? Does anybody know what is an example of reinforcement learning? Oh yeah, that's talking to the chatting artificial intelligence. Yes. Anytime it does a good job, I give it a thumbs up. Anytime it does a bad job, I give it thumbs down. So that's very good. Thank you. Yes, yes, thank you, David, as well. So pretty much what you think for reinforcement learning, what's another one? You know, if you guys, hopefully you're 16 or 17, you will want to get this, you know, when you're 17, on your 17th birthday, you'll want to probably go for the test. A huge hint.
Oh, like the SAT, ACT?
Oh,
wait, okay, never
For
mind.
driving.
Yes, yes. I mean, that's great. These are two huge tests. I should have been clear. Yes, the driving exam. Yes. You know, I mean, that is good, right? Yeah, maybe for that could be a little bit of reinforcement learning if you set it up in a certain way that you want to maximize your point on the SATs. But reinforcement learning could be like driving. I think, yeah, currently it's in yeah, so Wisconsin. Yeah, I think 17 for the license or so, or 16. Yeah, it really depends, as Lachlan is mentioning. So the idea is that if you guys are taking your driving exam, if you guys make some mistakes, you drive over a cone or something, you're gonna keep losing points. Points will be docked until like you might fail the test. So it's in your interest to do everything right, so that you know you drive, you stop when you have to stop, you parallel park properly, you indicate properly, you follow all the rules so you can maximize the points on your exam so you can pass. So similarly, that's the idea for a self-driving car. When they were training that car, they were almost training it like the goal for that self-driving car is to make it from point A to point B without crashing. That's the goal, right? Like to take you from your point to your destination without crashing, following all the rules. So every time when they were training those cars that now we saw in Waymo, they're not now like driving completely driverless now. Anytime they followed the rules, they would get points. Anytime they ran through a stop sign, they probably lost points. And then sooner, yes, these are how computer games learn your strategies, find better ways to play. Anytime you take something bad, it's like I'm your driving examiner. Anytime, okay, you failed to indicate or you did not look in your rearview mirrors, I'm taking off points. Then you're going to straighten up and you're going to learn, okay, wait, I need to do this to pass. And hopefully you guys don't aim to just pass, you aim to be like pros at driving. So like, you know, you should not just aim to pass, you should aim to like do well, like because that's your life at stake, you know, when you're driving. So I'm looking forward to it because I'm not a great driver myself. So let's see. So similarly for the super COVID-19 mask, because you guys were predicting, it's supervised data. So a key example in supervised data, we give the machine examples and we tell the machine what it is exactly. So it's like a toddler, we're training it with lots of examples. So we label the results. I give a lot of time labeling people with masks, for instance, people without masks. So, and then the machine can then figure out the patterns in the results. So in supervised, that's what we do. In unsupervised machine learning, what we do is that we don't give any examples. We just give the data, no labels. And we instead try for it to find patterns within the data. It's like nobody tells me who's friends with who in school, and I go and I observe and I try to find if there are groups of people who I think are friends. And reinforcement learning, it's like different, you know, we have a reward. What action should we take to maximize that? How do we drive better? How do we have the chat? How does a chat bot continue? Maybe the chat bot is measuring its success in terms of how much time I'm spending talking to it, right? If I get turned off by the chat bot, I'm like, oh, this is boring, it's not entertaining. Then it's not good, right? But if I continue engaging that, hey, yeah, you mentioned that I should see this this song, you recommended the song for me, or you recommended these videos, and I think that's cool. Why do you like them? Then I'm engaged. Or if I'm driving on and on without crashing, then that's also good too.